Hey guys, it's Mr. Robinson. It is topic 6, designing with forces. I know this will be our first online topic we're going to do together via Google Classroom. It's a little different, but I know you guys can handle it and we can make this work and get through it together. So here we go. So this is referenced in our textbook, which I did share with you in a PDF form, page 321. All the way up to, we're going to go right through to topic 7 and this also up to page 345. So 321 to 345, I would suggest reading that through maybe first before you go through this, and then this is kind of the big rocks from that. So looking at designing with forces. So designers rely on 3 key methods to help structures withstand forces. So we've talked a lot about different types of structures, and how they are different. For withstanding forces, the first thing we're going to look at is ensuring even distribution. So you can see from this comic that the force wasn't evenly distributed across the coffee table. It was put right in the middle and it caused it to fail. So I want you to think of what type of failure would that have been. So we have tensile, compression, torsional failure, shearing. What do you think that would have been, that failure there? So that's the first one, distribute the load evenly. Second one, make sure the forces hold things together instead of pulling them apart. So this ancient arch, these are the keystones in the middle, and you can see how the forces act on the structure. So the weight of the rocks above pushing down, and then the arch spreading that out down to the columns. And as you can see, it's quite a strong structure to be that old and to be still withstanding that force. Our next one, our third one, so shape the parts correctly to withstand the forces. So we see some braces here. We see a lot of triangular shapes in this home. These shapes, as you remember from our 2 labs, are the strongest. So those 3. Even distribution of the load across the structure, make sure the forces hold things together instead of pulling them apart, and shape the parts correctly to withstand the forces. So you're going to see this example of the swing. So just take a look at it. Look at all the different forces that are acting on it, maybe even pause. To see how this swing utilizes different forces. So we have forces, we have our rope in tension, our anchors in compression, that pushing down force, our torsile strength with the twisted force. Crossbar forms a triangle, so there again we see the triangle, and then the frame slanted again in another larger triangle for extra stability. You might have experienced this too when setting up a tent, because if these were maybe closer together, this swing and the people on it would probably have enough force to cause it to fall over. So that's why they're spread out in that larger triangular structure. So again, we talked about this, the force from above pushing down through those beams into those supporting columns, sorry. And this is in your textbook, so cantilever, so a long horizontal span with the big columns to help support it. So beams pull upwards on the board and beams from below push upward too. So you can see the distribution of force. There's an example of this in Edmonton, actually so much so it's a lookout point just on the river on the North Saskatchewan. And you can actually, so it's supported at one side, and if you come to this far end of it, you can make it move. It's a little scary, so if you're afraid of heights, don't go there. I'll search quickly and find what the name of it is. Yes, so the funicular in Edmonton, that's the rail car that will raise you up to the top, but yeah, the cantilever bridge, if you haven't seen it, check it out. If you go to the very end, you can make it bounce. So we're trusting the engineers and architects made it safe. So here's an example of a brace. So those additional supports, we saw a few of those here. right? There's braces there. So it's added materials that are angled to direct the force through the solid part of the structure, so down through those support columns. Solid beams are really strong but are hard and heavy to handle, so make strong beams that aren't too heavy, so hollow ones. So cylindrical columns, that's often used in foundations to ensure that, as you can see, it's hollowed out, making it have less mass, and so the force, the weight being pulled down in newtons is less, and it's less materials too for building, so it's cost effective. Corrugation, so it's a wave-like shape that gives strength. It also uses less material and is lighter. So you can see up close, you've seen this with cardboard, that's the extra material they put in between the two and maybe add it with an adhesive of some kind. As you can see, it makes a bunch of triangles. So take a break and go and search this, how it's made train tracks. So this link, you can't click on it, but how it's made train tracks, head over to YouTube and give the video a look-see. Here are some questions, but most of that's already in with material I've given you, so we're not going to do that now, but we'll just take a look. So rectangular frames are probably easiest to build. However, load forces can easily push or pull them out of shape. So you might have experienced that when we built our bridges and when we built our egg drop. Triangles are a sturdy shape. They are much stronger. Rectangle can collapse, but it's much more difficult to make a triangle one collapse. Frame structures contain many vertical supporting posts, and the weight is shared. So again, that idea of no single support taking all of the weight. Horizontal beam is supported at the end. It may bend at the center, so the solution is arches. So we saw an image of that. Cantilevers supported by strong horizontal columns at one end, and beams to help pull upwards. And then lastly, braces. So those three. So be able to define what each of those are. And then some solutions, large solid beams aren't used, so you can see I-beams are used, so they cut out some material because it still retains its strength, or hollow beams. So you could see in the form of an I, L, or T. We have corrugated cardboard, so you can see that at home when you're maybe doing the recycling. And then animal bones too, they're hollow, which makes them light, but also strong. Okay, and we took a look at that already with swings. So that for right now is it. So yeah, so that was topic 6 for us. And take a look on our Google Classroom for any additional materials related to this. Thanks, guys.